Hello everyone and welcome to the YouTube channel. Today we'll be talking about scripting on HPC for MPI programs. So in the previous videos we talked about simple C++ job scripts, OpenMP job scripts, and now we are talking about the MPI job script. They are slightly different from the OpenMP and C++ job scripts, and the fact that MPI requires a special statement during the execution. So let's get right to it. It's a simple hello world program, but with MPI. That's why it looks a little bit complicated. So I'm initializing MPI. I'm transferring MPI com rank. So that's for transferring the values, ranks, or basically IDs of the processes to the rank variable. Similarly, I am copying the size. That means number of processes to the size variable. And then I'm printing out hello from the processes. And let's get to the job script. So job script is very similar. The top portion is exactly same as in the C++ job script. You can check out the previous video for that. No changes here. The main change comes in the bottom of the script. So I have module load OpenMPI 4.1.6. Previously we didn't load any modules because we didn't need them, but here we do. Why? Because MPI requires MPI run. So any MPI executable requires this, because MPI can take in a runtime. You can define the number of processes, and you can set the number of processes during the runtime. That is why MPI requires this instead of a simple. There's no simple. You cannot simply type /a dot in case of MPI. Okay, sir, get right to the live demo. And currently I'm logged into a HPC param rudra. I'm inside the login node because compilation will take place here, and I'm inside the directory MPI programs. So I have hello world file here. Yep. I will need to load a few modules for this. So like I showed in the script, I will need OpenMPI 4.1.6 for compiling, and then I have to do MPI C++ for MPI hello world.c. Okay, the program is now compiled, and I'll simply just do the sbatch MPI underscore job script. Toss line breaks. Again, the same issue as in the previous one. We just need to change the file type to Linux. Sbatch, it will work perfectly fine. Now I can do a sq to check the job status, but most probably it will be done by okay. So it's still running. Let's see, let's check once again. It has requested for 4 nodes. That's why the program is taking too long. Let's also reduce the time to 1 hour. Yeah, it should be fine. And while we're at it, I can just cancel this job. I can show you how to cancel as well. So you just do 4058666. It's cancelled, and then I can submit a new job script. Check the job script. Only this one is running. And refresh. Yeah, now it's done. So you need to check for the job dot and then the job ID, whatever the system gave assigned it, and that dot output for the output file. Let's check the output. Okay, so it ran 48 processes by default. Why did this happen? I did not define any how many number of outputs I need, how many number of processes that needs to be launched. So since there were 48 cores available, it launched 48 processes. Let's do it once more. Now I have changed number of processes to 4. Let's see what result I will get. Okay, now it's compiled. I'm to check for 405870. 405870. Let's open it. Yeah, I've got 4 outputs from the 4 defined ones. So similarly, you can change the values here to get to set to multiple processes and get different outputs. The only difference, the only thing is that you need to load this module beforehand, otherwise MPI run would not work. And yeah, that is about it. And this is also required to avoid any kind of errors in the output or warnings in the output. Rest is as same as the ones in the previous videos, the C++ and the OpenMP videos. So that is it for today. Thank you for watching.